So in the next part of your notes, this example here, you've already seen that because we've got two different areas there, you will need to work out the area below the axis separately from the area above the axis. However, there is one piece of information which is clearly missing in this question, and that is this point here. So we need to work out, right, first of all, right, we need to find the root here. So remember, this is a representative, or this is a parabola, a bit of a parabola. So obviously to find the root, we're going to first of all set this equal to 0. So you're going to have to solve x squared plus 2x minus 24, and that would be equal to 0. And to factorise that, we would have x minus 4 and x plus 6. And of course that splits up into our two roots, so you get x minus 4 is 0, giving you x equals 4, and you get x plus 6 equals 0, leading to x equals minus 6. So those would be your two roots. So clearly the root here that we would be looking for, so this root at this point here, so in this case the root that we would be needing to use, the root would be 4. X equals 4 is what you're going to be using. So that helps us work out our areas. So we've got the two parts to work out. So of course we've got the below the x-axis part, and we've also got above. So of course to work out your below the x-axis, and you're integrating, and remember this will have a negative value when you do this. So you would be integrating between first of all 2 to 4, and you're integrating the x squared minus plus 2x minus 24, integrating all of that with respect to x, and that does of course give us x cubed over 3 plus you get 2x squared over 2, and you would have minus 24x, and then you put your limits on there, so between 2 and 4. And we would, before we sub in those limits, you would want to have simplified this here so that it just becomes x squared, and then you've got minus 24x. So with our limits of 2 and 4, we're now able to sub them in. So you would have 4 cubed over 3 plus 4 squared minus 24 times 4, and then you're subtracting, and remember you're subtracting all of this, so you're going to have 2 cubed over 3 plus you'd have 2 squared, then you'd have minus 24 times 2. So of course once you've written out that, there is only one further mark in the question like this, and that is to get to the answer. You can work it out a piece at a time just to make sure you don't put it all into the calculator at once, but you can use the calculator. This the numbers going on here would tend to be very much of a calculator nature. So remember, inside that bracket you've got 8/3 plus you've got 4, and then you've got minus 48, and they're all affected by the negative. So if you like, you could say that what you're putting into the calculator, even if you take the terms out one at a time, you've got minus 8/3, you'd have minus 4, and then you'd have plus 48. And if you deal with all of that in the calculator, you will get the answer of negative 17 1/3. But remember, this is representative of an area, so you would say area below the x-axis would be the positive value of that, would be equal to 17 1/3 units squared. So that's the first bit of this. The next part of it, you would then be working with area above the x-axis. So, and this time what you're doing is you are integrating from 4 to 5, integrating the same function. So you've got x squared plus 2x minus 24 with respect to x. Because we've already done the integrating part of this, and we've done the simplifying, we can just go x cubed over 3 plus x squared minus 24x between 5 and 4. So that would be 5 cubed over 3 plus 5 squared minus 24 times 5. Then you've got minus all of this, so you've got 4 cubed over 3 plus 4 squared minus 24 times 4. And again, you could deal with terms one by one. So you've got 125 over 3 plus your 25 from that, and from this you'd have minus 120. You could multiply out each of these terms, so you've got 64 thirds, you'd have minus 16, you then have plus your last term there, 96, and then deal with all of that in the calculator one by one. You would end up with 5 1/3. And because this is above the axis, we can write in that that is units squared, because we know that is the area. So we don't have to put a separate statement at that point. Your total area will be these two values added together. Your 17 1/3 that we found before plus the 5 1/3. So we would end up with 22 2/3 units squared. So it just can be a bit more complicated when you're doing these questions, if you have to find the root in the first place, and so that you can then get your limits in order to separate to work out the two parts of this separately. So the next question that we're going to look at on your this is an extra question that you can add in if you put it onto the back of the page and call it example 4. This is just to demonstrate that you have previously been introduced to integrating sine and cosine functions, so you can be expected to work out areas under these graphs as well. So it'll be the same sort of procedure here, it's just a wee bit more complicated to deal with for this particular example. So you would write down here, and remember that we would always be integrating with radians when you do this, so your limits are from 0 to pi over 6. The function you are integrating is the sine of 3x plus pi over 6. We can write at the front of this, because it's all above the axes, that we are actually working out the area and the curve, and we should have our dx in there as well. So please make sure that you do include the integral sign and the dx with it. So you would look to your formula to integrate this, and the integral sign is going to give you negative cos, and the fact that we've got this 3x going on, that's our 1 over a part, so we would have negative 1 over 3 cos, and you've got 3x plus pi over 6, and all of that is within your limits, 0 and pi over 6. So when you sub into this, you would have upper limit negative 1/3 cos, and you're doing 3 times your pi over 6 plus the pi over 6 that's also there, and then you are doing minus 1/3. So that means we're doing that minus 1/3 of the cos of 3 times 0 plus the pi over 6. And if we simplify all this out, so we get negative 1/3 cos. At this point it is okay to start thinking in degrees. So your pi over 6, right, that's 180 divided by 6, which is 30. So you're going to have 3 times 30 going on there. So you've got a 90. So it's okay to think about it in that way. 90 plus the 30 that's already there. Two negatives together here means I'm doing plus 1/3 of cos. And this expression here, obviously 3 times 0 is 0. You've got plus pi over 6, so it's just the cos of pi over 6 that we're doing. So that would lead us to negative 1/3 cos of 120 plus 1/3 of cos pi over 6. Now clearly if this was in a paper 1 it'd be a non-calculator question. You'd be expected to know your 60-30 triangle or your values if you've memorised those, and also be aware that an angle of 120 degrees would take you into the second quadrant, and the related angle that you would therefore be using would be the 60. But of course the cos is also negative in that second quadrant. So if we know the cos of 60 is positive 1/2, that means the cos of 120 will be negative 1/2. So you'd have negative 1/3 times negative 1/2. And then for the second fraction, you'd have 1/3 times the cos of, we should probably have written that actually in degrees. Did mean to write that in degrees, seeing as we've got the other one in degrees. So right, we've now got the cos of 30. So cos of 30 we know is root 3 over 2. So we've got 1/3 of root 3 over 2. So multiplying all that together, that's going to give us positive 1/6 at the front, plus this one here gives you 3 over 2, 3 times 2 on the bottom there, which is 6. So what we end up with is both of these fractions are 6. So we can just add the top terms together and just write it all as a single fraction. So your area could therefore be equal to 1 plus root 3 all over 6 square units, right, without the calculator. So just a wee bit more complicated when it involves a sine or cos expression, but it's still all the same processes.